Hello everyone, welcome to Aviation Engineering YouTube channel. Alright, so today I'm going to teach the module 15 gas turbine lesson number 2 part 2. Alright, so I think this one also having more few parts like part 3 and part 4. So just stick with me, and because so many people they ask me, my subscribers especially, they ask me to do the gas turbine. So don't worry, I will I will finish this module also for you guys, and after that I will try to discuss or just some questions regarding each and every lessons. All right, so please subscribe Kwiation Engineering, and today I'm so happy because few days ago my channel reached 3,000 subscribers, and thank you very much for you guys subscribing my channel, and it's very happy for me. All right, so yeah, that's all I want to tell, and let's go to uh, the lesson. And also I want to tell, I'm doing in parallel module 15, I'm doing module 11 lessons, and also Boeing 777 type training lessons, and the A320 type training, and also in future I'm looking forward to do Boeing 787 type training lessons also. All right, so stick with Aviation Engineering YouTube channel. All right, so now let's go to the lesson. All right, so let's go to the module 15 gas turbine lesson 2 part number 2. All right, so let's see what is the content. So today I'm going to teach for you guys energy heat engines and thermodynamic engine, and we are going to discuss temperature scales and Newton's law of motions and Bernoulli's theorem and convergent duct and divergent duct. All right, let's go to the lesson. All right, the first one, energy. Yeah, so everyone's know what is energy, right? It's very basic thing. Like when you stay, when you are in your high schools or secondary schools, you learn about energy. So let's discuss, because this is a part of this module, right? So energy, yeah, energy is what makes things happen, right? Energy is what makes things happen. It can't be created or destroyed. Well, as you learned before, energy we cannot create or we cannot destroy, right? So it can only be changed from one form to another. Just remember, energy we can change only from one form to another, but we cannot create it or we cannot destroy it. All right, so there's only a limited amount of energy in the whole universe. Remember, there is only a limited amount of energy in the whole universe, right? One day all the energy might be spread out evenly. So when that happens, nothing will move, no work can happen, right? So when the energy spread all over evenly, all right, when energy is spread out, so what happens? Nothing will move, no work can happen, and everything will be stopped, right? So this idea is called the entropy, right? This idea is called the entropy, right? So now let's see different type of energy. They have different type of energy. So there are some common forms of energy. Okay, let's discuss what are they. Number one, heat energy, right? So the heat energy travels in three ways. What are these ways? Radiation, conduction, and convection. Okay, radiation, conduction, and convection. So radiation means like heat from sun, and the conduction means like heat moving through a metal rod, right? And the convections means like hot air rising, right? So it is called disorderly energy, right? This is called disorderly energy because it's move randomly and it's hard to control. All right, so next one is fuel or chemical energy. Fuel or chemical energy, right? So fuel or chemical energy found in petrol, batteries, or food, right? So called orderly energy. Is called as orderly energy because it's stored neatly and is easy to control. And the third one, kinetic energy. So kinetic energy is like energy of movements, and any moving objects like a car or a ball has kinetic energy, like it's linked with the momentum, right? So potential energy is the energy due to the position. Okay, potential energy potential energy happens because of due to the position, right? So example, a ball held high above the ground has potential energy. So if dropped, it becomes kinetic energy, right? If we drop the ball, it's become kinetic energy. And then next one, number 5, electrical energy. So caused by moving charges like electrons, and flows from negative to positive, and like heat is moved until the energy levels out. All right. So the last one, the sixth one, pressure energy. Pressure energy is in liquid or gases under pressure, and the fluid will try to move from high pressure to low pressure, and while doing this it can do work like turning a turbine. All right. Okay, so now let's go to the heat engines. Let's go to the next one, the heat engine. Yeah, what is heat engine? What is heat engine, right? So a heat engine is a machine that turns heat into useful work. Okay, so heat engine is a machine that turns heat into useful work, like moving a car or turning a turbine, right? So it works by taking in heat and then using part of that heat to do work, and then release the heat, releasing the rest of the heat. Okay, I mean the heat engines work in three ways. How? First they take the heat and then they use that heat to do work, and then they release the rest of the heat, right? So how does it work? Like a basic cycle, we talk about basic cycle. Like a heat engine always works in a cycle with three main steps. So the first one is heat source, second one work output, and the third one heat sink, right? So the heat source means it gets heat energy from something hot like fuel burning, and the work output, some of that heat energy is used to do work like pushing a piston or turning a wheel. And the last one, heat sink, is the leftover heat is thrown away into something cooler like the air or water, right? So example of the heat engines, you can say car engine, steam engine, jet engine, power plant engines, right? Power plant turbines, right? So the car engine means like burn fuel to push the piston and make the car move, and the steam engine heats water to make steam that turns the wheel, right? So the jet engine use heat to create fast moving air and thrust. Okay, this is important for us. And the power plant turbines burn fuel to make electricity, right? So there's an important point is no heat engine is 100% efficient. Remember, right? No heat engine is 100% efficient. Some heat is always lost as a wet heat, usually into the air or cooling system. All right. Okay, right. Now let's go to the thermodynamic engines, right? Thermodynamic engine. Yeah, what is thermodynamic engine? What is thermodynamic engine? So a thermodynamic engine is a type of heat engine. It converts heat energy. Heat energy, we can make a symbol as a Q, into mechanical work is W. Okay. What is thermodynamic engine? Thermodynamic engine is a type of engine. It convert heat energy into mechanical energy. Just remember. So, but here is the key, right? It can never convert all the heat into work. Okay. In the thermodynamic engines, we cannot convert all the heat into work, right? Some energy is always lost. It's not 100% efficient, just remember, right? So how is it work? Basic flow is like heat source gives heat energy to the work, uh, heat energy to the engine, and the engine turns part of the energy into work, and heat sinks. The leftover heat is Q minus W. Q means the heat energy and the W is work. Then the leftover heat means the Q minus W is released into something cooler, like air or water, right? So what is a heat sink? Now let's learn what is heat sink. A heat sink is a place where the waste heat is dumped, right? Heat sink is the place where the waste heat is dumped, right? So it is usually cooler than the engine, right? It is normally usually cooler than the engine, like the air around the engine and the cooling water or radiators. All right. Okay, now let's go energy flow summary. Let's see the energy, the how is flow, right? Heat source, we take the heat source and it's go to the engine, and then engine it's work, right? And then plus rejected heat, right? So then it's sent to the heat sink, right? That is the normal cycle. So you can also explain this using the first law of thermodynamics. So energy in, okay, in energy in equal work out plus heat lost. Okay, that is the first law of thermodynamics, right? So you can see the way the Q is the heat source, work done plus Q minus W is the heat sink. Okay, right? Heat lost, right? Okay, you can just go through this normal diagram. Okay, all right. Yeah, now let's go to the temperature scales. Yeah, this is also very important, temperature scales, right? So why do we use different scales? Why do we use different type of temperature scales? Why we cannot use only one, right? So in thermodynamics, we measure temperature using different scales depending on the context or the countries, depending on the country or the context. All right, so the scientists use the Kelvin scales, and in the USA engine makers often use the Fahrenheit, and in most other countries like people use Celsius or centigrades. In some thermodynamic calculations, you may also see the Rankine. Okay, Rankine. Let's see the temperature conversion formulas. They have different types of temperature conversion formulas, right? So to switch between the scales, remember these formulas. This one you have to remember, right? Sometimes for the exam, they will tell you, okay, just convert this amount of Celsius to Fahrenheit like this. Okay, all right. So now let's see Celsius to Fahrenheit and Fahrenheit to Celsius. To convert Celsius to Fahrenheit, you must like Fahrenheit the Fahrenheit equal 9 upon 5 into Celsius amount plus 32. Okay, that is the amount. If you know the Celsius, then how to calculate, how we convert to the Fahrenheit, then you have to example, right? So yeah, you example, if you know the Celsius here is 10, yeah, so then 9 upon 5 into 10 Celsius plus 32, that is the Fahrenheit amount related to 10 Celsius, right? So now to convert the Fahrenheit to Celsius, now you know Fahrenheit 50 Fahrenheit, so then how you calculate 50 Fahrenheit? Yeah, Celsius equal 5 upon 9 into Fahrenheit, like 50 minus 32, that is equal to Celsius amount, right? Okay, example one. Normally you have to know 1 Celsius equal 1.8 Fahrenheit. Okay, 1 Celsius equal 1.8 Fahrenheit. Yeah. So now let's see Celsius to Kelvin and Kelvin to Celsius, right? So Celsius to Kelvin, you have Kelvin equals Celsius plus 273. The opposite side, 1 Celsius equal Kelvin minus 273, right? So Kelvin is used in thermodynamic calculations. There are no negative values in the Kelvin scale, starts from the absolute zero. Remember, the Kelvin scales start from the absolute zero. Okay, all right. So Fahrenheit or Rankine, Fahrenheit to Rankine, and Rankine to Fahrenheit. So one Rankine Rankine equal Fahrenheit plus 460. Okay, right. So if you know the Celsius and then you need to convert to the Rankine, so what you have to do, first you have to convert to the Fahrenheit, then you have to add 460 to get the Rankine. So Rankine is like Kelvin but used with the Fahrenheit. All right, so example conversion like 0 Celsius equal 32 Fahrenheit, and 100 Celsius equal 212 Fahrenheit, and 0 Celsius equal 273 Kelvin, and 0 Fahrenheit equal 460 Rankine. Okay. All right, so now let's go to the Newton's law of motion. Okay, this is also very important, Newton's law of motion, right? Sir Isaac Newton gave us 3 basic laws that explain how things move, right? So Isaac Newton gave us 3 basic laws that explain how things move, right? These laws are very important in aviation and engine operations also, especially in gas turbine, right? So let's see, we go to the Newton's first law, the law of inertia. Right, the Newton's first law, this is called the law of inertia. So what is the law? Every object stays at rest or move in a straight line at a constant speed unless a force make it a change. Okay, just remember, every object stays at rest or moves in a straight line at a constant speed unless a force make it change. All right, so in simple words, when we explain this one in simple words, a thing won't start moving, stop, or change direction unless you force act on it. Okay, right? So if you want to move or stop something, you must apply a force. All right, example, an aircraft on the runway stays still until the engine thrust or brake for apply a force. All right. Okay, so now the Newton's second law, force and acceleration. The rate of change of momentum is proportional to the force applied and happens in the same direction. Okay, the rate of change of momentum is proportional to the force applied and happens in the same directions. The formula is force equal mass into acceleration. This is very famous formula, F equal m into mass into acceleration. Okay, so in simple words, you can say the more mass or the more speed you want to change, the more force you need. Okay, so direction of the motion change in the same as the direction of the applied force. Remember, the direction of the motion change is the same as the direction of the applied force, right? Example, heavier aircraft need more engine power force to take off. Okay, all right. So now the next one, last one, Newton's third law, action and reaction, the law is for every action there is an equal and opposite reaction. Okay, so in simple words, you can say if you push something, it pushes you back with the same force. Forces have always come in pairs. Okay, so example, gas turbine, the engine pushes hot gases backwards, the plane move forward thrust in the same thrust. Okay, all right, so here there's a small graph like law, simple explanation, and real example. The first law, things don't move, change unless pushed. Okay, that is the simple explanation. And the real example, plane stays still unless engine runs. So the second law, more force equal more acceleration, and the more thrust needed for heavy jets. And for the third law, the simple explanation is push back equal push forward. Real example, jet engines create the thrust by pushing air backwards. All right. Yeah, now let's go to the Bernoulli's theorem. Bernoulli's theorem. Yeah, it is very important in the aviation, right? So what does Bernoulli's theorem says? What does the Bernoulli's theorem says? In a moving fluid, like a air or liquid, right? In a moving fluid, the total energy at any points at the same. Remember, in a moving fluid, like air or liquid, the total energy at any point, the total energy at any point stays the same, but it's shared between pressure energy, kinetic energy, and potential energy. Just remember, okay, in a moving fluid like air or liquid, the total energy at any point stays the same, but it's shared between the pressure energy, kinetic energy, potential energy, right? Understand? So if one goes up, another must go down. Okay, it means like pressure energy plus kinetic energy plus potential energy is a constant, right? So if one goes up from these three, another must go down to balance it. Okay, to keep the total energy constant. So in simple words, when air moves faster, the pressure drops. From this one, the simple words you can understand, like when air goes faster, so then the kinetic energy increases, its pressures goes down. When air slow down, the pressure increases. Okay, so this is how velocity and pressure are connected in the following fluids. Okay, all right, flowing fluid, not following, is flowing fluid. Okay, all right, so now the Bernoulli's energy equation is total energy equal pressure energy plus kinetic energy plus potential energy. Okay, so it's like having a fixed amount of money shared between three pockets. If one pocket gets more, the other must get less. Okay, so the real life example, gas turbine on aircraft, when air enters a narrow duct like a jet engine, it speed up. According to the Bernoulli's theorem, its pressure must be decreased. So this principle is used in carburetors, venturi tubes, jet engines, and aircraft wings lift generation. Right. Okay, so now let's go to the convergent duct. Yeah, convergent duct. What is convergent duct? Okay, so this is the convergent duct. Okay, this is called the convergent duct. Yeah, what is convergent duct? A convergent duct is a tube or passage that gets narrow. Okay, is get narrow, right? So a convergent duct is a tube or passage that gets narrow from the inlet to outlet. Okay, you can see it's this duct get narrow from inlet to outlet. Okay, so yeah, so wide at the beginning and narrow at the end. So what happens when the air flows through it? When air flows through the convergent duct, the area gets smaller, and so the air speed ups, but the pressure and the temperature drops. Okay, so energy exchange based on the Bernoulli's principle, kinetic energy increases, air move faster, and the pressure energy decreases, less static pressure, and temperature also drops, less thermal energy. Okay, so the total energy stays the same, just converted into different forms. Yeah, so this is the ducts as you show I before. So in the convergent ducts, just remember these kind of things can come to the exam. So in the convergent ducts, the velocity increases, pressure decreases, and temperature also decreases. So where is it is used? The convergent ducts are used in the jet engines like air intake, and the venturi tubes, nozzles, aircraft carburetors. Okay, all right, so now let's go to the divergent duct. Yeah, the other one, divergent is like this, it's getting wider. Yeah, so the divergent duct is a tube or passage that gets wider from inlet to outlet. So the narrow at the beginning and wide at the end. Okay, you can see narrow at the beginning and wide at the end. Yeah, well, so what happens when air flows through it? Yeah, when air flows through the divergent duct, the area is increases, so the air slows down but pressure and temperature increases. Yeah, so the energy change based on Bernoulli's principle is kinetic energy decreases, air slows down, and the pressure energy increases, the higher static pressure and the temperature also increases. Okay, so just like in the convergent duct, the total energy remains constant but it shifts between forms, right? Yeah, okay. So where is it used? Divergent ducts are also used in diffusers, right? In jet engine and compressors and subsonic engine intakes and aircraft environmental control systems. Okay, you can see in the divergent ducts, velocity decreasing, pressure increasing, temperature increasing. All right. Yeah. Okay, that is the end of this lesson. Thank you for participating this lesson also, and just waiting for the next lesson. I think lesson number 2, part 3. Stick with Kwiation Engineering YouTube channel, and please subscribe and Kwiation Engineering YouTube channel, and also share these videos with your friends and relatives. Yeah, that's all I will tell, and see you on next lesson. Have a great day for all of you.